I wanted to bring back a question we get a lot in different formats, but basically how to solve faster in Flux. Obviously, we don't like it when it's slow, and there's a lot of things we can help. You can do to help the solving to go faster. We'll try to go through the different categories, but the main part is really being sure you use the right solving options. Obviously, in terms of geometry, you don't want to solve the whole model of whatever you're studying. So for example, you're doing an electric machine, then you're going to maybe do a 2D cross-section, simplify some details, and use periodicities and symmetries so that you end up with something much simpler in the solver. Then the second step would be to mesh your device. So again, in the mesh, there are some tips and tricks. Some of them is obviously to relax the mesh, to have less mesh elements, but it's also important to mesh right all the important parts. So anything like the air gap, or if you have like skin effects, if you don't mesh these aspects really well, it's actually going to take longer to solve, even if you have a large mesh, because it will not converge very easily, so it will not solve faster. In terms of the physics itself, there's also a lot of things that could be done. Some of the recurrent things we see is that typically using some of the advanced homogeneous region, like having the coil region with losses, having the thin conductor region, having the surface impedance region, can help your solving to go a lot quicker most of the time. So whenever you can use these, try to use them. One thing we see also a lot at the support is non-clean material curves. So whether it's the pH curve that is not very nice, or if it's like a temperature dependent property, we tend to have a lot of trouble when the curve is not nice. So this is one of the things you can also check if you see that the project is not solving well. And same thing for the circuit. So there's a lot of potential things you can do badly in the circuits. Some elements like diodes and switches can be not your best friend. So you need to check that everything is well defined in this. And maybe more importantly, on the solving part, so first of all, the scenario itself. So if it's a transient scenario, try to make sure you have the right time step. If it's too long, you might miss something and the convergence may be difficult. If it's too small, then you will have too many steps, so it will be too big to solve. And especially since a few versions now, we've added a lot of things regarding the recommendations for the solving. So whenever now you check the physics before solving, it will actually display something like this, which can help you identify if you've used the right settings. So some of these settings are the choice of the solver. So it can say MUMS or PETSI. So MUMS is the direct solver, is the best one for smaller models. It works well with big models, but it can be memory intensive. So if you don't have enough memory, you might need to switch to PETSI, which is then the recommended one for very large models in general, which uses a lot less memory. So make sure to check what these two boxes say, the current setting and recommendation. And you can see it's talking also about number of cores and parametric distribution. So these are the two things as well you need to use well to your advantage. So first, regarding the parallel solving, when you are in Flux, important that you realize what number of cores will be the best for you, for your project in particular. So that's one part. And the second part is when you're doing parametric study, some people don't even know they can do this. So it's very important that you remember this and you check that you're using it. This is the parametric distribution. So now, since a few versions, it's very simple to set up. You just need to go into this set local resources in your supervisor options. And from there, you can specify how many flux you want to be able to run in parallel and how many cores per flux. And once you've set up that, you just need to do parametric distribution enabled on your scenario in your project. And when you have this, it means that instead of solving one step at a time, it will solve, in my case, let's say 4 steps on 4 different cores to save you a lot of time. So for any 2D parametric study, this is very, very helpful. Even for 3D models, if you have enough memory and cores, this can be very efficient as well. So make sure to set those local resources and have this enabled on your machine, because this is probably going to save you a lot of time for parametric study. And just so you know, so if you need to go a bit further on this topic, there's a lot of documentation that have been added over the last years. So if you go into this how-to document, there's a whole section, how can I speed up my solving? So make sure to check this documentation. There's a lot of things regarding these topics and also regarding the HPC. So if you need to go towards HPC, submit jobs, this is also a good place to start looking.